To get this experiment to work, we had to create a fixture to hold the bases. So what you're seeing in these next clips is a block of tooling board in our CNC machine. This machine is very high speed, very accurate. We take the computer model, and in this case we're cutting a reverse of it such that we can set the plastic bases in, clamp them, and position them very accurately so we can machine the various groove configurations that we want to test out. What you're going to see in this clip is the automatic probe. It's going to come down and bump 4 points on the edge of the plastic part and find the exact center. It's a very neat system. Next, you're going to see the cutter, and first I filled in the plastic parts with an acrylic resin, which you can kind of see in the groove area, and then we went back in and with this cutter and machined the very small grooves so that we could have O-rings. In this case we're doing 2 very small concentric grooves, and in the case of base A and base D, just a different width and depth for the current O-ring gasket. Here you can see a view that shows all 5 configurations, and the attached PDF defines those for you. Next, we're going to do all of our testing with a hydraulic pump, and the gauge that you see here is 0 to 300 pounds. We had very hard time controlling the pressure. What we found is the pressure inside the vessel was actually giving us back pressure whenever we took our hand off the lever. and as you're going to see in a few minutes, this is actually going to explode. This is one of the new nylon clamps, and you're going to see it fail at about 155 psi. After this point, we switched to testing with the water, and with the pump I have, the highest pressure we can get is 135, 140. So I thought it'd be interesting for you to see this failure, and then you're going to see it again in slow motion.
25, 100, 150, 100, 150.
Here's the slow motion sequence of that clamp failing. I experienced the same thing as Chris, where the pin on the thumb screw actually broke. You're going to see the gauge right at about 155 right there. I was a little discouraged by this. This was a very beautiful setup, and I was hoping to use it for all of the testing, but as you can see, it was totally destroyed on the first go around. Fortunately, no one was injured. We've now switched over to the setup where we're testing with water pressure from a submersible pump. We'll be able to achieve about 140 psi. The gauge that you see in all the rest of the images is 0 to 200, so 12 o'clock is 100 psi. The first configuration that we're testing here, we're using the production clamp, the ones that were made in August of this year. What I was surprised to find is that this failed even lower than we thought. You're gonna see it break at 100 psi. Very discouraging that these are so weak, but it is something we can learn from, and I'll also show you the sequence of this clamp failing in slow motion.
Look for any leaking.
20, 30, 40, 50, 60, 70, 80, there's 90.
We'll take a look at that again in slow motion. Watch the pin where the thumb screw joins. You can see that it's breaking right at that point, and in this case at about 100 psi. The next configuration that we're going to test is the current production base with the groove as it is, a little bit wider than we would like, but according to the Marco rubber design. So this is the current production base with the new clamp, the nylon clamp, and it performed very well. No leaking and no breaking, but as you've experienced, right around 80 pounds or so, sometimes there's a little bit of burping, and so certainly works, but I think you'll see that it can be improved. Again, this is the current configuration with the new clamp, and as you'll see, it holds the pressure very well, no leaking, up to the maximum that we could achieve, which is right around 135. We'll zoom in on this gauge here so that you can see that. This is the maximum pressure that I can achieve with the current pump that I have. Next, we're going to see the best configuration, or at least the one that we got the best results from. Base A, we filled in the groove, remachined it so that the width of the groove is the same as the width of the O-ring cross section. This is the Marco rubber -359 with a cross section of 210. I think we made the groove 215 wide, and we made it 5 thousandths shallower than it was before. You're going to see that there's no leaking anywhere from 0 to our maximum pressure, and you're going to see when it gets up to the 140 or so, it just holds the pressure beautifully.
Maybe this one stretches a little bit and doesn't break.
Could be.
I don't know.
Okay, let's fill it with water with everything wide open.
Everything's wide open. All right.
Yeah.
Slowly to 100.
We should be able to go up to full pressure.
Full pressure, yes. Okay.
What we want to see is right around 40 to 60 to 80. Is it leaking at all?
There's 20, 30. There's 40, 50.
I don't hear any creaking
60,
or anything.
I don't see any leaks. There's 70, 80, 90, there's 100, continue up. There's 110. There's 120. There's 130 or a little bit more. That's not shut off all the way. I can shut it off if we need to. There's full pressure.
Okay, we're at the highest pressure we can achieve here. Right around 135, and we're getting no leaking. Very nice.